Hello? Hi everyone. Today we will continue to look at the content of HCI-Storage. Today we will specifically look at how data is written into solid-state drives. First of all, solid-state drives. Right? As one of the most important storage devices. Its writing mechanism we have only briefly introduced before, right? We briefly introduced it, so today we will specifically guide you through its basic performance and working principles. So first, let's take an 8-channel example. Using the 8-channel example, let's analyze how to proceed. To write data into the solid-state drive. Alright, firstly, the main controller is our core component, right? It is responsible for coordinating and managing the entire data storage process. So first, the main controller is connected through our 8 channels. Currently 8 channels, connecting to 8. Flash memory chips, connected to 8 flash memory chips. Here we have only illustrated what? Just illustrated a block on each chip. This way, it's easier for everyone to see. In reality, what is it here? It's 8. Dies, the bare dies of the flash memory chips. Here, we have used 8 blocks as a substitute. Then, each small square here represents a configuration. First, we assume the size of the configuration to be 4 kilobytes. This is equivalent to our entire setup being a large warehouse. Each flash memory chip is like a section of the warehouse. Each block is like a shelf in our warehouse, and the configuration is like an item on each shelf. Small compartments are used to store data. This is our overall structure, right? Next, let's take a look at the process of writing data. We first write to this. First, we write 4 KB of data into our block. When the user wants to write this 4 KB of data, first we will write to this. For example, in the first block, we first write 4 KB of data, which exactly occupies 1 slot, right? Well, at this point, it's like we've filled a small compartment on a shelf with goods, right? It fits exactly 4 KB. This kind of single configuration write operation is the most basic unit of data writing in our solid-state drive. Because here, the smallest unit is actually writing into one of our configurations. This is essentially the most basic write operation. And then, well, this is the issue with 4 KB, so let's change it. Let's switch to 16 KB. If we write 16 KB this time, how do we write it? Well, it's like this. It will be like, for example, from 1 to 4. Each of the 4 blocks will have 4 KB of data written. 4 times 4 equals 16 KB. No problem, right? Each one gets 4 KB. This is equivalent to placing a small compartment on different shelves in different warehouses, each with a configured size. 4 KB of content. So why write it this way? So everyone can think about it. Why not write it this way? Why don't I just directly write this 16 KB into the first block? Well, writing into 1, 2, 3, 4 configurations, why not write it like this? Everyone can think about it. Now if you assume we just write into this one block, think about it. We write this 20 KB, 1, 2, 3, 4, 5. It requires 5 configurations, right? However, our channel only has 1 path, so if you write 5 configurations, it's equivalent to, in this 1 channel, we have transferred 20 kilobytes of data. Okay, now let's go back and take another look. If I write simultaneously into these 4 blocks, where with each line writing 4 kilobytes, wouldn't the speed be faster? This is equivalent to us being able to take advantage of multiple channels to increase our data writing speed. It's like, hey, you have, for example, if you have 4 tons of cargo to transport to a warehouse, and you only deliver it to 1 warehouse. The door is only so big, and if you want to bring in 4 tons of cargo, you will need to spend, for instance, 10 minutes. But if I divide the cargo into 4 parts and deliver them to 4 different warehouses, isn't that like going through 4 doors? Then for 10 tons maybe, hey, in 2 or 3 minutes, hey, it's in. It's in the warehouse. This is actually the advantage of multiple channels. This is the same as our warehouse. Both are for storage, right? In the warehouse, we store our specific goods, and on our hard drive, we store our specific data. It's essentially the same thing. By entering in parallel and utilizing the advantage of multiple channels, we can do this. It can greatly increase our speed, improve our efficiency. Then, as we continuously write data, so, for example, here it would be like writing one by one when you have filled everything up. For instance, when all these blocks are completely filled, once the entire block is written full. It's like all the slots on a shelf are filled. At this point, this section is full, right? It's full. When this section is completely filled, our main controller will play its role in managing. It will select the next block, ET, to continue writing. Once it's full, it won't write anymore, as there's no space left, right? After it's full, it will continue to select some blocks that still have empty available space to continue transferring data. Here generally, our main controller will use algorithms and strategies to select the appropriate block, mainly to ensure the efficiency of our data storage and our lifespan. Here, we generally try to adopt the wear leveling strategy. Balanced writing to prevent wear. To prevent, If everything is written on the first block, it might break in just a couple of days. So being able to write here is very important. Here we use a multi-channel approach mainly to enhance performance, to fully utilize our hardware resources, to allow multiple flash chips to work simultaneously, thereby speeding up our write speed. This is the reason why we need a multi-channel approach. Next, we also need to understand the importance of configuration and blocks in our storage. First, configuration is the smallest unit of our storage read and write operations. Here, the smallest unit of configuration is 4 KBs, while a block is the smallest unit of erasure. What does this mean? Please pay attention here. When we store data, it is stored one configuration at a time. But when erasing, it is not erased by configuration. If you configure it, this is relatively what? It can be quite troublesome because its unit is inherently very small. When erasing, it is based on what? It is based on erasing the entire block. For example, in one of our blocks, there are many configurations, and when you need to erase, it's equivalent to erasing all the configurations inside at once. Because during the data writing process, you need to reasonably manage the configuration and block. If, let's say, your configuration isn't fully written yet, and you need to erase the block, that's definitely not okay, right? That would be pure waste, right? If you haven't fully written it, and you're already erasing, then the other empty space, right? This will actually accelerate the wear of our block. You can't frequently erase and write to a particular block, right? Here everyone must pay attention, and also when you are using it. When using a solid-state drive, you must be cautious. When writing data, only write the data you need, and if you don't need it, write less. Solid-state drives have a lifespan, and this helps with that. This is one of the points, right? Of course, in practical applications, such as servers storing large amounts of data, or personal computers quickly storing files, the multi-channel writing mechanism of solid-state drives can significantly improve the efficiency of our data storage. For servers, fast read and write capabilities can ensure that in high concurrency business scenarios, large amounts of data just uploaded by users can be stored promptly, improving the response speed and stability of the service. As for personal users, it comes into play when copying large files. For example, when dealing with high-definition videos or large installation packages, the high-speed write performance of our solid-state drives can greatly reduce waiting times, enhancing the user experience. Overall, the data writing process of our solid-state drives is actually a relatively complex and sophisticated system process. It involves the scheduling of our main controller, multi-channel parallel operations, as well as configuration and block management, among other aspects. So here, first of all, through today's explanation of the overall writing process, everyone should first gain a deeper understanding of the writing process of solid-state drives. Of course, this is the first part. In the first part, we will discuss the second part of the writing process in the next lesson, and there will be some other content as well. This is a basic writing process, the most fundamental writing process. If anyone wants to learn Huawei certification technology, or wants to obtain the Huawei certification question bank, please send me a private message. You can also leave comments below the video for technical exchanges. Alright, let's stop here for today.